Hello and welcome back to your 16th intermediate Java tutorial. So today we're going to be talking about the difference between static and instance variables. So let's go ahead and make a new project, and we're going to go ahead and call it tutorial 16 static versus instance. Alright. Static versus instance. Let's close these two. We're going to make our package. There's going to be two examples in here that I'm going to show you guys today. So yeah, 16. All right. So let's go ahead. Let's make a class called test. So test here is going to have an instance variable, and then it's also going to have a static variable, and we're going to look at the difference between the two. So let's make a public int instance int. So this instance variable is has a every time you make a test object. Okay, so actually let's backtrack. We're going to talk about the difference between a class and an object. So see what we've got here. We've got a class, right? And then when you do, test t equals new test, that's creating an object. So a class is just a declaration of it's just a set of instructions for an object, and objects are the actual implementation. So that's the difference. So when I say objects, that's what I'm referring to. So an instance variable, it has one value for every individual object of the class. So every time you call a new test, it's going to have its own instance int value. But when we have public static int, static int, we can call it static int for convenience, it's going to have one value for every object. Think of it as a shared variable amongst all of the test objects. And it can be used outside of the class. It can be used anywhere. So okay. So first, let's make a constructor. So public test int instance int, right? Or actually, I'm going to show you guys a neat little thing in Eclipse. Static. Sorry. I'm going to show you guys a neat little thing in Eclipse. You can go to source, and you can click generate constructor using fields, and it'll do that. So there we go. We don't want to call super though, so let's delete that. Alright, so public test. So we've got this constructor. So this constructor is when you call new. And then this instance int is given a value. Yet static int is not given its value yet. And it's you could give things values in constructors, that's fine, but it's not best practice because it's always better to do it a different way, unless you're only going to have one instance of that class and you just want a static integer so that you can use it anywhere without creating an instance. So that's when you would put it in a constructor, but just for now, let's not put it in the constructor, so that we can take a look at it later. So all right, so let's make a void in there. Public void. We're going to increment int. Okay, so we're going to instance int plus plus, right? And then we're going to static int plus plus. So this is rule number 1. This is a non-static method. Static variables can be used in a non-static method. Alright? However, if you were to make a static method, public static increment static int, you cannot use a non-static method or integer or a field or anything in a static method. So you can't even call increment. You can't even call this because it's not static. Or this dot. Right? Cannot be used in a static context. Okay? So you can only use static variables and methods inside of another static variable method. That's why I think it's in generic methods. I remember we did have that. All these methods here are all static because we cannot use these in a static void. So, yeah, fun fact. Alright, so that's done. So let's go ahead and let's look at let's make our main class. So main 1, and it's going to have a main. Okay. Alright, so this is a static method. So it's always best just to declare whatever's going to start running your program in here so that you don't have to worry about the whole static stuff. So yeah. So first and foremost, so sys out. So to access a variable in a static way means to do the name of the class, so capital, the name of the class, dot, and then the variable. It already is giving a static int. So instance int, you cannot access this integer. You cannot access the integer because it is an instance integer, and it can only be accessed through an object, not through the class itself. So you can see we're going to get it's a compilation error. Cannot make a static reference to the non-static field. So note that you cannot do this. All right. So let's look at some stuff. So string.format. Default value. Alright. We're going to give it an integer. We're going to look at test.staticInt. So this is how you access a static variable. So as you can see, this took on its default value for its type. So every type in Java has a default value. So Booleans are default to true, I believe. I think they're defaulted to false. Ints are all numbers are defaulted to 0, and all objects, all non-primitive types are defaulted to null. So keep that in mind. It automatically has its default value once you run the program, once the program compiles. You can then give it a value, so you can do test.staticInt equals 2, and then you can run we're just going to copy this. And this is value after setting. Okay? So it sets it to 2. And then you call the static methods in that class the same way. So test.incrementStaticInt. And we're going to just copy this. Value after incrementing. Right, and it's 3. Alright. So, and also you cannot call test.increment. You cannot call a non-static method in a static way. It'll tell you that. You cannot make a static reference to a non-static method. Alright? So you cannot do that. So, how do we access that instance int? Well, as I said, instance ints are for instance variables are for objects. So we have to make an object. So let's make two test objects. We're going to call the first one test1. And we're going to give this one the value of 5. And test2 is going to have the value of 2. Look at that. Alright. So let's look at this. So sys out, and we're going to string.format. And we're going to do initial test1 instance int and %d, and that's going to be test1, and you guys remember how to access variables in an object. You just do that dot the variable. So right, it's 5. Alright, so we're going to copy this, we're just going to show that they are different. Oh, they are different. So we call test1 instance int, you get 5. And test2 instance int, you get 2. So an instance variable is different, has a different value for every object. All right. Well, they can have the same value, and sometimes that's used to check if the objects are equal or not. But they don't have to have the same value. So, okay. So we're going to string that format. We're going to do something that's kind of a no-no. So test1, we're going to look at the static int. Static int. And we're going to do %d. And we're going to give it test1.staticInt. You can do this, but the thing is that you're calling it's a static variable that you're not calling in a static way. It works the same. It's just not recommended. It's just a no-no. So don't do it. I'm just doing it to show you guys, to prove a point. So static2, look, the static int and static1, they're both 3. So it's the same value to the same variable. And then let's just do sysout. Let's access it the correct way. Test static int. So this is actually calling it in the static way as we are supposed to. So as you can see, it's 3 for every single one. So let's go ahead and increment real quick. So let's do test1.increment int. Right, so this is going to increment the static int and the instance int. I'm going to go ahead and make a suppress warning to main so that it doesn't bother me about that. Alright, so sysout, let's go ahead and just do string.format again. Test1 instance int after incrementing test1 and %d, and then we're going to do test1.instance int. Okay, so after incrementing, we saw that it was once 5, the initial value for the instance int, and now it's 6. So let's go ahead and let's do test2 instance int after incrementing. And you can see that it stayed the same. It was unaffected by the instance int being incremented in test1, as you would assume. But let's go ahead and let's look at the static int. So test1, I'm just going to copy this. Let's copy that. Oops. Copy too much. And then just do after incrementing test1. Just add that before the semicolon of each one. And again, unclose it. And we're going to go ahead and do the no-no again by accessing a static variable in a non-static way. So what happens? It was incremented on all the occasions, on to static 1, 2, and the static. So because we know why that happened, because it is one value for every single test. It's for every single object. You don't even have to have a test object. And that will actually lead us into our next example, where you can have classes where all you have are static variables, and you don't have to make an instance of that class, or you won't even have an object, yet you can still use the class. So we're going to go ahead and do that. We did something like that. Actually, not something like that. We exactly did that in the myInput class in the games that we make. We make I like to call them a static class. It's not. Don't quote me on that. That's a really wrong thing to say, but it's just how I know. So we're going to call this no instance. Okay. So we're going to give this an array. So we will not have an instance of this array, or of this class. So we can't have a constructor. So as I said, we weren't going to put this in the constructor. We could if we wanted to, but if you're not going to make an instance of a class, then putting a constructor in there is kind of useless. So how do we initialize variables and these objects or arrays? Because an array's default value is null. So if you were to try to use an array without giving it a value in the program, you would get a null pointer. So we're going to go ahead and we're going to make what's called the static initialization block. So think of this like a constructor. It runs right as the program is being compiled, and it creates this array here. It gives this array a default value essentially. So now in here we can do array equals new int and give it the array value. So I'm just going to go ahead 1, 4, 8, and 1. So remember, this is the static initialization block. So you can give static variables initial values and create the objects. And again, these values would be shared across all instances of the class, even if in this case it won't because we're not having any instances. But if you were to have like a static initialization block in here, set static ints to like 3 or something, so static, so let me actually show you it in action. Static int is equal to 5. You can actually see that the default value is now 5. Alright? So let's go ahead and let's make our main 2. So main 2. Alright. So without making an instance of no instance, we're going to be able to use it. So first we're going to go ahead and just print out opening and closing curly brackets or square brackets. So just this would be print. Yeah, everything's just going to be print on the same line. So we're going to do for int I in no instance dot array. And because it's public, we can just access it without having a getter. So sys out, we're going to go ahead and print I plus a comma and a space. Even though it's not really accounting for the second to last or to the last one, that we don't need a comma and a space after that, but that's fine. So 1, 4, 8, 1, and comma space. So it printed out 1, 4, 8, 1. Okay? So it was able to do this because we gave this array a value in the static initialization block. If you were to comment this out, you wouldn't have any compilation errors, but you definitely have a runtime error as a null pointer exception. Okay? And that's basically all you need to know about the difference between static versus instance. Just think static is universal, right? I could go into, singletons and all that, but I feel like if you know the difference between static and instance, you will run into a singleton and you'll be able to do it. A singleton, think of it as a no instance type thing, except for instead of having no instance, you have exactly one instance of it, and they're all non-static fields, but it has a one static instance of it to use across the program. I personally don't like it. I'd rather just do like a no instance type thing and always just call it like this. But hey, that's fine. That's my personal preference. But yeah, I know Unity people like to use singletons, so it's really just the community you're working in. So yeah, I'm starting to ramble, so I'm going to stop. Another thing I need to say is I know I've been doing a lot of these like really weird ones. From now on, I am actually pulling directly of what our AP Comp Sci teacher, Mr. Clark, has planned to do before the test. And I want to cover those myself before the test because I know you guys prefer to have someone other than him teaching. Or you guys just want something else or something that you can watch over and over and practice at home. For whatever reason, you guys would, this could be helpful for you. So from now until, you know, I only have like 5 tutorials planned after, or 4 after this one. So, but after this one and until probably the end of the intermediate series, I'm probably going to end it with the end of the AP Prep. It's going to be AP Prep. So if you're an AP student, you're going to make use of all of these. Okay, so I'm done rambling now. So thank you guys so much for watching. Leave your questions and comments in the comment section. I love hearing your feedback. And yeah, I'll get to you. And suggestions. Actually, no suggestions. No more suggestions on games, because I'm actually working on asteroids, and I will make a tutorial when I'm done, and it will be the Club Rush demo. So yeah, so this video has gone on like a couple minutes longer than the actual tutorial itself now, so I'm going to stop it now. So thank you guys so much. Love y'all. See ya. Bye.